Welcome to this lecture. In the last few lectures, we had looked at requirement specification, and we saw that that is a very important issue. Before starting to develop, it is very important to know the exact customer requirements, find out if there are any difficulties with the requirements, and then eliminate them, and finally document that in a acceptable format. And we had seen the IEEE 830 format, which is accepted across all industries and academics, and we had seen the different elements of the requirement specification, the functional requirements, non-functional requirements, and so on, and then how to document this. Now, let us start looking at the structured analysis and design. We had also seen some very basic concepts about design, namely the high level design, detailed design, and also what can be considered as a good design in terms of modularity, cohesion, coupling, layering, and so on. Now, let us start to discuss how to go about doing procedural design of a problem. We assume that the requirement specification is done, complete, documented, and we would like to start doing the procedural design for the problem. Let us see how we go about and address this issue. In this lecture and next few lectures, we will address the topic of structured analysis and design. This is a top down decomposition technique, in the sense that we will start with very gross or coarse level requirements, that is as specified in the SRS document, the functionalities that the system should perform. You start from there, and then we do a top down decomposition, meaning that we break the required functionalities of a system into finer levels. And for this purpose, we will use the data flow diagram technique. We will use the data flow diagram technique, the DFD, to do the functional requirement analysis. We will model the requirements and we will decompose into smaller functions. But before we started, it is good to know that why we need to model the functionalities. We need to model the functionalities because we will do the requirements exploration and validation. By this we mean that the functional requirements as specified in the SRS document will take exactly the same functional requirements and we will break them down into simpler functions in a hierarchical manner. What we mean by that is that if this is our SRS document and we have in the functional requirement section, we have various functions listed there. We will take each function and we will use DFD to model this system. We will represent all these functions and also we will decompose this into finer functions. Each of the functions will be decomposed, and even the sub functions will be decomposed through the DFD technique, and finally we will have a set of fine granularity functions. So, this we call as the functional requirements exploration, because starting from very gross level requirements specified in the SRS document, we decompose them into functions which are very small in size. And once we achieve this decomposition, we will be ready for starting the design. So, in the structured analysis, we do the functional requirements exploration, that is break the functions into fine functions, and then once we have a fine set of functions, fine granularity, we then start the design. But before we start looking at the structured analysis and design, we will just do a small digression, just have a small digression. We will contrast the function oriented and the object oriented styles, because right now in this hour and next few hours we will be looking at the function oriented design, and later we will be concentrating on the object oriented design. These are two distinct design styles. The function oriented or the procedural design is a top down design technique, as we were saying that we start with the requirements, take the functionalities specified in the requirements and decompose them hierarchically into a fine set of functions, and then we map them into a design structure, and we use the structured analysis and structured design for the procedural design technique. And then once we have got the design, then we can easily code it into using a language such as C. On the other hand, object oriented design technique is a bottom up technique. Here, based on the requirements, we first identify the objects, and then we see the object relations, if there are any. I mean, there will be many relations, and then we model the object relations to build a hierarchy. So, we start with the basic objects, and then we group the objects into classes, and then classes into a inheritance hierarchy, and so on. So, this is a big difference, that function oriented is very intuitive, top down approach, and object oriented is a bottom up approach. We start with objects and build from there, and we will use the UML notation to do the object oriented design. That is, as soon as we complete the procedural design, we will get started with the function with the object oriented design. And once we have the design ready, then this can be easily coded in a language like Java, C++ or C#. Okay. So, now let us get into our discussion on structured analysis and design. So, here as we were saying that we will start with the high level functions as specified in the SRS document, and then we will decompose into detailed functions. So, that we call as the structured analysis. So, this is the structured analysis activity where we do a functional decomposition. On the other hand, immediately after the functional decomposition, we will start the structured design, and here we take the functions identified in the structured analysis. If these are the set of functions that are identified in the structured analysis, we will discuss a technique called as the structured design technique, which gives a methodology how to map this set of functions, fine level functions, into a module structure, and this will form our high level design. We will first discuss the structured analysis, where we identify the fine grained functions, and next we will look at the structured design, where we discuss how to decompose, how to map the fine grained functions into a module hierarchy. Now, for the next hour or so, we will look at the structured analysis, where we do a top down decomposition starting with the functions identified in the SRS document. We split into sub functions and fine grained functionalities. This diagram just explains this concept. We will identify the set of functions that are there in the SRS document. If these are the set of functions, for each function we will decompose that into sub functions. How do we decompose that? We will be discussing. We will use the DFD notation for modeling this decomposition, and then each sub function into further sub functions, and same thing we will do for the other high level functions mentioned in the SRS document, and at the end we will have this set of fine grained functions, and this we will map into the design structure, the high level design in the structured design technique. The structured analysis and structured design technique is well accepted by the developers. Anybody wanting to do a procedural design would do the structured analysis and structured design, but then there are various flavors of this design. For example, you may use the Constantine and Jordan's methodology, or Hatley and Purvey's methodology, Gain and Sarson's methodology, DeMarco and Jordan's methodology. So, what I want to say is that there is no standardization of the methodologies. We can find in different industries using different methodologies. These are largely the same, but then there are small differences in the notations and so on. We will point that out, and for our discussion we will be using largely the Hatley and Purvey's methodology. We will see that the different tools that are available, they also support number of methodologies, and different industry and different projects they might adopt some methodology. Hatley and Purvey is a methodology which has come much after Constantine, Jordan, Gain, Sarson. So, this is a more recent methodology, and obviously, they had the privilege of making use of the ideas on the Constantine, Jordan, Gain, Sarson, DeMarco, Jordan's methodology, and we will be using the Hatley, Purvey's methodology to a large extent. And once we do the structured analysis and structured design, we will have the high level design. In the high level design, we will have the module structure, and in the module structure we can use this to code the design for coding and the final implementation. Now, let us see how do we achieve functional decomposition, because this is one of the main objective of the structured analysis, to do a functional exploration or functional decomposition. Here, through a hierarchy of levels, we decompose each function into sub functions and so on, and as we decompose the sub functions, at the same time we will observe that the data also gets decomposed. Starting from the very high level data that are mentioned in the SRS document, we decompose that simultaneously and automatically into detailed data, and finally, we have primitive data elements at the lowest level in terms of integer, character and so on. For doing the structured analysis, we will use the DFD technique. DFD stands for data flow diagrams, and this is a very intuitive and simple technique. It takes hardly few minutes to get familiar and get productive and get started using this technique. And because of its simplicity and utility, this technique is extremely popular not only in the procedural design, but also in many other applications. For example, in the SRS document itself, in many projects they develop the DFDs, because this gives a good understanding of the functions into a finer level of activities. And also the DFD model is a very intuitive model, and by just looking at it we get a good idea about what the system needs to do. As we were saying that the structured analysis technique is a very simple technique, do not need to be even knowledgeable in computer, anybody can start using this technique. And it represents the customer's perception of the problem. It is not really a design technique, it just keeps on elaborating what the customer wants of the problem. So, this is a detailed model of what the customer really wants of the problem, and for this we also use the customer's terminology for giving various names to the data, to the functions and so on. And no wonder that this technique is easily understood. The models developed using the DFD are easily understood by the customer, even though customer may not have computer exposure. Therefore, once the designers they complete their structured analysis, the DFD model of the system, it can be reviewed by the customers to check whether it has missed any of their requirements and whether it has correctly captured their requirements. Based on this idea that this is a very simple technique, can be learned in just few minutes, we can learn this technique and start modeling various problems in a very short time. But let me just tell you that it is easy to learn this technique, but then for finally using this technique to model various problems, we need bit of practice. We will define a set of assignments. You can carry out the structured analysis model of this technique using DFD and then check whether you are doing it right. And once we have completed the structured analysis, we will start the structured design, and here we will map the fine grained functions into a module structure, and this module structure is also called as the software architecture. One thing we must be clear is that the structured analysis is just an elaboration of the things that the customer wants. On the other hand, in structured design, we arrive at a form that can be easily implemented, that is coded into a solution. Obviously, the form structured analysis, if we have done the structured analysis, we cannot derive a code from that. But once we have converted the structured analysis into a high level design using the structured design technique, that can be easily coded into the solution. Just to recapitulate what we discussed, the structured analysis is a top down decomposition approach. We know what we mean by top down decomposition, and it is a divide and conquer principle. It uses the divide and conquer principle because we look at all the functions in the SRS document, but take each function one by one, and then at a time we decompose one function, and then we decompose it into sub functions, and again at a time we look at one sub function and again decompose it, and that is exactly is the divide and conquer principle. And it is a graphical technique. We will use the DFD, which is also called as bubble chart, to represent our result. The DFD allows us to do a hierarchical decomposition, and that is why the DFD is a hierarchical graphical model. We will have various levels of model. Some are very high level model, and then these are further decomposed into finer or more detailed levels. And at each level we will represent the functions or the processing in the system, and also the data interchange among the processes. This is an example of a DFD model. We will use the circles to represent the functions or the processes. That is the terminology. Either we can call these as bubbles, processes or functions, and then these take some input data, produce some output data. Because this is a data flow model, so it represents how the data flows within the system through the various functions. Please remember that this is not a control flow model. It does not say that which flow occurs first and then which one occurs next and so on. It just represents the data flow. Basically, what are the functionalities at this level and what data they consume and what data they produce. We will see the other notations that are used here in few minutes. As we were just saying that each function is represented using a circle, and this represents some processing. It takes some input data, does some processing and produces some output data. The model is extremely simple, as you were saying. Without much effort, we can easily understand a model developed using this. Just let us look at this car assembly unit modeled using the DFD notation. So, here the processes are fit engine, fit door, fit wheel, paint and test. You can observe here that each of the process represents some activity, and that is why these are starting with the verb form: fit engine, fit door, fit wheel, paint and test. So, every function represents an activity or processing and is named using a verb form, that is doing something, and then each process or bubble here, it takes some data. It takes engines from the engine store, takes chassis from the chassis store, and then fits the engine to the chassis. The chassis with the engine goes to the next processing station, and here the doors are obtained from the door store, and to this chassis with engine the doors are fitted, and this we call as the partly assembled car. and then to this the wheels are fitted by taking the wheels from the wheel store, and then we have the assembled car. This is painted and tested, and the final output is the car. So, the model is very intuitive. Just by looking at the model, we can make out that what really happens. It is a very simple technique, as you are saying. We will see that in very small amount of time, we can start doing the DFDs for various problems. One of the main reason why it is a very simple technique is there are only 4 or 5 types of symbols, actually 5 symbols to be precise. We can learn the 5 symbols in no time. The set of rules by which we combine these symbols to model a system is very simple, and also it is a hierarchical model. We start doing something very simple and slowly add more details to it, and therefore, while even developing a very sophisticated model, we find that it becomes easy. So, with this discussion about the DFDs, structured and introduction to structured analysis, we will stop here. We will continue from this point in the next lecture. We will see how to use the DFD technique, what are the nitty-gritty of the DFD technique, and how to use this to model any given problem. Thank you.